A fully loaded Boeing 777 weighs approximately 650,000 pounds. A solid metal tube of this mass should plummet straight to the Earth the second it leaves the tarmac. Flight is a calculated mechanical manipulation of the physical environment. This manipulation is the basis of aerodynamics, the study of how gases interact with solid bodies moving through them. To understand how a commercial jet stays aloft, we have to look past the machine and focus on the invisible physical forces acting upon it. When an aircraft leaves the runway, it enters a continuous four-way physics battle. Weight is the first force. Gravity pulls the aircraft's mass straight down toward the Earth. As the plane moves, it encounters drag. This is atmospheric friction pushing backward against the nose of the aircraft. To maintain forward motion, the engines generate thrust, providing the propulsion required to overcome that friction. Finally, the wings generate lift, an aerodynamic force pushing upward to counteract the aircraft's weight. This creates a state of equilibrium. For a plane to maintain level flight, the forward thrust must mathematically equal the backward drag, and the upward lift must equal the downward weight. If this mathematical equalization breaks, if any one variable drops out of the equation, the aircraft falls. There is a common misconception regarding how jet engines keep a plane in the air. The engine turbines do not point down towards the ground, they point backward, which means they provide absolutely zero vertical lift. Their only structural job is to generate enough thrust to overcome the horizontal force of drag. The engines drive the aircraft forward fast enough so that the wings can perform the work of lifting. The necessary upward lift is generated by the wings. This cross-section is an airfoil. It is curved on the top and relatively flat across the bottom. This shape utilizes Bernoulli's principle. As a fluid's speed increases, its pressure decreases. When oncoming air hits the leading edge of the wing, the flow splits into two paths. The air traveling over the curved top has a longer path to cover, so it accelerates, creating a zone of low pressure above. Slower-moving air under the flat bottom bunches up, creating high pressure. High-pressure air below presses upward into the low-pressure zone above, creating the force that pulls the wing into the sky. A second mechanism of lift allows a pilot to physically angle the aircraft to generate more upward force. This is the angle of attack, the wing's upward tilt relative to the air. This engages Newton's third law. For every action, an equal and opposite reaction. The tilted flat bottom acts as a plow, forcefully deflecting oncoming atmospheric gas downward. Because the wing shoves a massive volume of air forcefully down towards the Earth, that air shoves the airplane up. Pull back from the micromechanics, and the plane is in a state of calculated equilibrium with the air around it. The atmosphere surrounding the aircraft is a dense physical medium. It is an ocean of invisible gas, possessing its own weight and resistance. The aircraft functions as a submarine, engineered to navigate this fluid sea. Flight is the result of aligning these four forces with the physical properties of that fluid ocean.